Okay, did we all pick 3 of them? Just on the front. You probably want to skip all the back, but we're not actually skipping anything. All right, so first of all, this ISN, you can just ignore that. I just didn't take that off. You can put your name on it. We're not actually putting an ISN. But so if you picked 3 that you'd like to skip on the front, how many of you picked number 2? Raise your hand if you picked it. It's okay. You probably all picked most of the same thing. How many of you picked number 4? All right. And how many of you picked number 6? All right. What else did, who picked something other than those? What did you pick?
I chose the 1, 2, and 5.
What? Oh, you wanted to skip the easy ones. Look at you. All right. Did somebody else raise their hand? You put 8? Okay. 8 gets messed up a lot. Okay. All right, good. So I know why y'all don't like 2, 4, and 6, right? Why? Fractions, exactly. So it's not that bad. But like I said, number 1 hopefully should be, and so we're gonna do them all, but I know that y'all don't like the fraction ones. I know number 1 is easy. Okay, I know it is. How would most of you start that? Distribute. Okay, we could distribute the 6, right? Absolutely nothing wrong with distributing 6. But what did you say, Cassandra? Divide by 6. Okay, so we could divide by 6. We got to make sure we know when that's legal and when it's not. And a lot of times that will make it a lot easier. Here, whether it's easy or not is a matter of opinion. But what if those numbers were 62 and 57? Then would you want to distribute? Probably not if you didn't have a calculator, right? But if you look at this, inside the parentheses, there are 2 terms there. But overall, for the equation, there's 1 big term here and 1 big term here. And so if we look at this first term as 6 times those parentheses, we can totally divide both sides by 6. Those cancel out. I get n plus 5 equals what? -3. Okay. Now, I am not telling you you have to change the way that you would solve things. I just want you to see in some of the things that we do that there are other ways to do things, and make sure you know when things are legal and when they are not, because that's when our careless mistakes come in, or when we assume things that aren't really true. So then we subtract 5 from both sides, and n equals -8. Okay, everybody okay with that? All right, good deal. All right, so on number 2, I know a lot of us didn't like number 2 because of the fraction, but is this fraction really that big of a deal? No, it's probably pretty easy to get rid of that. I would start by doing what? How can I get rid of that fraction? Multiply by 4. So I'm gonna multiply this side by 4, and I'm gonna not just 4, but -4, right? Yeah, -4. Sorry, I think that's what y'all said, and I just said 4. So on the left, those cancel out. That's the whole reason we did it, right? So we get 3 times 5 minus 3x equals, now I'm going to have a negative times a negative, so that is positive. And what is 4 times 15? 60. All right. So if you're having to multiply with 25s, think of quarters. If you're multiplying with 15s, think of times. 4 15 minutes is 60 minutes. Also, when you multiply by 4, you can multiply by 2 and then multiply by 2 again. Sometimes that makes it a little bit easier, okay? So then we get 60. Now, I know, and I don't always skip a bunch of steps up here because I don't want to lose anybody as when you're looking down and stuff. And it is okay to skip steps, but when we skip steps or we just try and do a whole bunch of steps at once, that's when your careless mistakes happen. And a lot of the mistakes that happen with solving simple equations is not that you don't get it. It's just that it's something ridiculous. You're like, oh, I just messed up the negative, or oh, I just did this. And that's true, but we have to figure out a way to, stop that. So we could distribute the 3, right? But would it be legal to divide by 3 here? Yes. So we can go ahead and divide this whole thing by 3. Notice I'm not dividing inside the parentheses because that's 1 big term. Those cancel out. So I get 5 minus 3x equals 20. So then I would subtract 5 and get negative 3x equals negative 15. X equals 5. Okay. Everybody okay with that? And again, if you would have gone about it, what did I do? Oh, shoot. Never mind, y'all. I told you my head is hurting and I'm very sleep deprived. Yeah, that's wrong. -3 equals positive 15. I don't know where I got -15. And then when I divide, x is equal to -5. Thank you. Now, not saying that's the best way to do it. I think it just is maybe a little bit different than what most of you would do. Not all of you, but I think some of you didn't even necessarily know that those things are legal. Depends on who taught you what, really. Okay, so now let's look at number 3. Could I start off on number 3 by dividing both sides by 2? No. I mean, technically I could, but I would have to divide. I have 3 terms. I'd have to divide all 3 terms by 2, and that's definitely not going to be helpful here, right? Because the 5 and the 29. So instead, I want to move the 5. So let's do that. We'll get 2 times 2 minus 7y. I'm going to add 5 to both sides, so I get -24. So now I could distribute the 2. Could I divide both sides by 2 here? Yes, I could do that here. And a lot of times this makes your numbers a little bit smaller, so it's, maybe it is better than distributing. It's up to you. 2 minus 7y equals -12. Okay. Then we would subtract 2, get -7y equals -14. Y equals 2. Okay. Everybody okay with all that? Any questions? If you're like, this is ridiculously boring, that's actually a good thing. But if you have a question, make sure you let me know. We'll get into some others that you're not going to think are boring. Okay, so let's look at number 14. I'm 14. See, oh my God, y'all. We're going to look at number 4. I could distribute, but I know most of y'all didn't like number 4 because you don't like the fractions. I could distribute and I could deal with the fractions, and that's absolutely fine. You have to deal with fractions no matter what you do on here. But we could also start off like we did on the other ones and divide by what's being multiplied out here. If we divide by a fraction, what's our rule? Multiply by the reciprocal. Good. So I'm going to multiply this side by -16/15. And I'm going to multiply this side by -16/15. Are the 16s going to cancel out on the left? What do we think? On the left, are the 16s going to cancel out? No. It would have been nice. Kind of was hoping that was going to happen. But if I put 16/1, when I multiply, it's going to become positive. I do have to know 16 times 16. What is that? 196 is 14 squared. It's 256. So I get 256/15. Okay. Now, remember, you will be able to use Desmos the entire time in the SAT. You will be able to use the calculator in college algebra. I am going to let you use the calculator. They're actually on the back counter. I'm just going to get labels for them for you first. But we still have to understand the process, right? So that's why you don't have a calculator in your hand. Now, over here, the whole reason we did this was so that this cancels out with that. And I'm left with 4/5 Q plus 32/3. Okay, everybody okay with that? Yes. Now, I would like to get rid of these fractions. So what do you think I can multiply by that would be helpful here? 5. We can multiply through by 5. And what? And 3. And what's 3 times 5? 15. Now, however you see this, it will work. You can multiply everything through by 5. That would cancel this one out, and then it would reduce that. Or you could do the 3, or you could do them both at the same time. So if you kind of think about it kind of like finding a common denominator, and whatever your common denominator would be, that's what we're going to multiply through by, and that'll help things. So I'm going to multiply this by 15, this by 15, and this by 15. And remember, it's like 15/1. So when we start to reduce, those 15s cancel out. And that leaves me with a 256. Now here, when I do 15, I don't have to do 15 times 4. I can cross cancel. Remember how we looked at that? 5 goes into 5 once, goes into 15 3 times. So that gives me 3 times 4, which is 12. And then here, this is why cross canceling is helpful. 3 and 15, 3 goes into 3 once, goes into 15 5 times. So I do have to do 5 times 32, but that's better than 15 times 32, right? 5 times 30 is 150. 5 times 2 is 10. So that's 160. Okay. What am I going to do next? Subtract 160. So what's 256 minus 160? 96. Do y'all agree with that? So tell me how you did that so quick. What'd you do? Did you manipulate the numbers in your head? What's your process? Tell me what your process.
I guess the closest way I saw it was 60 plus 90 is like 150.
Okay. Okay. So that worked. No, it's okay. Because sometimes you can't explain it. It's okay. Here's what I would do. So I'm just going to kind of jot down my thought. I would probably maybe write something down. But so if I'm going to do 256 minus 160, I mean, we can borrow and stuff. Y'all know how to officially do the subtraction. But I would start by subtracting 100. So now I'm at 156. And then I'm going to subtract 60 more. Well, if I actually take 56 of that away to get me to 100, then I would have to subtract 4. I'd have to subtract how many more? 4 more. And then that's going to get me to 96. So however it works, if you got to borrow and do whatever, do what you got to do. And then that's equal to 12Q. Now, if you know your multiplication facts, you can do 96 divided by 12. We don't all know our multiplication facts. So there's other ways to do it. You can say Q is equal to 96 over 12. And then, okay, they're both even. So I can divide and get 48 over 6. And then maybe we know that one. What's that? 8. Q equals 8. But 8 times 12 is 96. What questions we got? Anything? That one was icky no matter how you look at it. But all right, let's look at 5. Actually, you just go ahead and do number 5. There's nothing all that special about it, except it doesn't come out to a whole number. Don't give me a decimal. Okay. Are you buying your votes with these cookies? Yep. Did you get a cookie? Oh, you already voted? Did you vote the right way? Yes. Check with your neighbors. It's okay. Oh, you can leave it as an improper fraction. I know we were practicing the mixed numbers. You just leave it. Okay, so does it really matter? Okay, I just it's just pure curiosity. There's not a right answer. It really kind of depends on who your algebra teacher probably was, right? But raise your hand if you move the variables first, like the ones with the variables. It's okay. Don't be ashamed. I like to see it. Okay, so then raise your hand if you move the constants first, the other numbers first. Okay, and then some of y'all just didn't do it. I don't know. It was kind of half and half. I always move the variables first, not because it's necessarily the right way to do it. I never really paid attention to what I was doing because I don't teach it from scratch, but I'm sure that that's the way it was drilled into my brain when I learned it. But it doesn't really matter either way. But so I would move and also move it to where it makes the most sense, right? I'm not going to move my 10a over here because that makes a bigger negative number. So I'm going to add 6a over here. I get 16a minus 7 is 21. 16a equals 28, right? So then A equals 28 over 16. Now remember, you don't have to, not that this is a crazy difficult number, but I can look for the biggest number that divides into both, or you can just take a couple steps. They're both even, so I can divide by 2, 14 over 8, and then they're still both even, so that's 7 over 4, and I can't reduce it anymore. And a mixed number is fine. When we did the fractions, I had you practicing the mixed numbers so I could make sure you knew how to do it in case you had to, but we can leave it. Okay. Everybody good? Yes?
Is there a reason you hate decimals?
I don't hate decimals, but if that was 7/3, then what are you gonna do? Right? You know what I mean? Or like 5/7. Like it's just icky. Fractions are just nicer. It's easier. It's easier when you substitute them back in. Like if I had to substitute that number in, 7/4 is way easier to deal with than 1.25. 1.75. See, I can't even do it. I can't even say it right. 1.75. You're right. Whatever it is, but that's a very good question. All right. Let's look at number 6. Now we could start by distributing. Do you want to start by distributing, or you want to get rid of fractions? We can get rid of fractions. We like to get rid of fractions, right? If I want to clear the fractions, what would I multiply by here? 6. I can do 3, and then I would have to go back through and do 2, but you can do 6 to begin with. Don't forget, this is the problem with clearing fractions, that you have to multiply every single term. So this multiplied by 6, this multiplied by 6, and this multiplied by 6. I'm not multiplying inside the parentheses because that's one big term there. When I do it with the first one, the 6's cancel out and we get 5w plus 6 times 21 . 6 times 20 is 120. 1 times 6 is 6, so that is 126, or however you come up with it. Make sure you are able to do it by hand. Yes, you can use the aid of a calculator, but we have to be able to do it as well. And then this is negative, so don't forget your negatives. These are the careless mistakes that happen that just make things wrong. What's 6 times 1/3? 2, because it'd be 6 over 3, it is 2. So I get 2 times 2w minus 9. We okay over there? Do you want your next step to be to divide by -2? No. In this case, I'd say no, because that's an odd number, and then I just get another fraction, right? So it's not always the, I mean, it's possible, but I wouldn't do it. So I'd go ahead and distribute that. And note, if I'm just going to work with the right-hand side, you still need to write down the left-hand side so your stuff makes sense as you go through. So this will give me -4w. And some of you may need to, or maybe already, do this. If when you distribute, you constantly forget to do both, even though I know we all know better, draw your little arrows. Some people draw the little arrows and still don't do it. I don't know how to help you then. You're on your own at that point, I guess. And then this is plus 18. You don't even pay attention to yourself. I don't know how to help you. And so then we get 9w plus 126 equals 18. What if I'm going to do 126 minus 18? I know it's going to be a negative number, and it's still going to be in the 100s. It's -1 what? 08. Now, is 108 divisible by 3? Do you remember how to figure that out? Okay, you add them. Guess what? That works for 9 also. 1 plus 8 is 9, which is divisible by 3, but it's also divisible by 9. So that trick works with 3 and 9. So that means I know it goes in there evenly. I should know that anyway if I know my multiplication facts. And 9 goes into 10 once with 1 left over. So we get -12. Okay. What questions do you have? Anything? Okay. Before we get to number 7, let me ask you this. If I have 2x plus 3, no, let's do 6. 2x plus 6, no, wait. Oh, no, I was right the first time. Sorry. I have it written over there. What I want to do. And I divide by 2. Can I just cancel these 2's out and end up with x plus 3? No, that's a big fat no. All right, Victoria, sit up. So this is a hard no here. Bad, bad, real bad. If I have 2x plus 6, I can divide that evenly, and here's why. I don't know if there's always have to do this step. We'll talk about that in a second. But if I factor out in the numerator and get this, then I divide by 2. Now we can look at the numerator as one big term, and that definitely cancels out. So be very careful on that stuff. This kind of stuff gets you in big, big trouble. Hey, if you can't stay awake, you could go get a schedule change. I'm fine with that too. All right. So if I look at number 7, could I start by dividing everything by 5 or negative 5? Like, is there a way for me to do that legally? I'm not trying to trick you into an answer. I can. I don't even have to necessarily factor. Just like when we're clearing the fraction and we multiply, right? As long as I multiply every single term, even though this is addition or subtraction there, if I divide this by negative 5, I can divide both of these by negative 5. As long as I do every single term, I'm good. All right? And so these are going to cancel out. I'm left with 8p plus 6. And then 5. Hey, you too. Sit up. 5. If I have to be awake right now, so do y'all. All right? And I'm struggling. Y'all can see that. 5 divided by negative 5 is what? Negative 1. And then these negative 5s cancel out also, so that would be plus p. Okay, so that absolutely works. Again, if you're uncomfortable with that and you would rather distribute, there's nothing wrong with that at all. I just want you to see some other things that, especially if numbers are weird, as long as you know when it's legal, that it might be helpful in some situations. Okay, we can all still learn something. So I'm going to get 7p equals negative 7. P equals negative 1. Okay. Now, Lauren, since you told me 8 was one you wanted to skip, can you tell me why? Did you just not like it, or is there something specific? Okay, that's okay. Because this is one that I can tell you mistakes are going to be made by lots of people, especially if I don't talk about it right now. And what do you think that mistake is? Where do you think that mistake's going to happen? Not distributing the negative, exactly. Okay, and that is, and I know y'all know to do that. The reason I think there's so many mistakes is because you look at it, you think it's easy, and you're not really thinking about what you're doing. That's why you mess up on the easy stuff. So there's no number there, but you have got to distribute that. Lauren, I have a feeling that's been a mistake for you before, and so somehow you have trauma, and that's why you knew when you saw it. I'm not trying to call you out, because I'm just saying, I promise you, all of us in here made that mistake. So you just knew, like, I don't like that one. All right. And so this is going to, and I'm going to leave the right-hand side the same. So I'm going to get 16 minus 7m, and then what? Minus 3, exactly, equals 8 times 1 minus m. And I can distribute the right-hand side. I'm thinking on the left, I don't know that dividing by 8 is going to help me. And it's okay to do more than one step at a time. I'm actually going to leave the left like it is just for a second because I want to point something out. 16 minus 7m minus 3 equals, and then that'll be 8 minus 8m. Because here's something else weird I see sometimes, even from those of you that have really good skills. And again, it's not necessarily wrong. I just don't know that you realize you're making your life harder. If sometimes y'all are just doing stuff and you're not really paying attention to what you have and thinking about it as you go. I will see students that have something like this, and then they'll add 3 to both sides here. Again, not wrong, but it would be way better for you to actually combine your like terms first, right? So don't forget to do those things, because then you just have more work, and then sometimes you start to make things up. So 13 minus 7m equals 8 minus 8m. And then which m would you move? The 7, okay. So we'll add 7m to both sides. So 13 equals 8 minus m. So then we'll subtract the 8 and get 5 equals negative m. So what does m equal? Negative 5. How many of you would have moved the 8? Me too. Does it matter? No. As long as you don't mess up your signs, you're fine. Also, y'all know it's okay to have your variable on the right in the end, right? I mean, if you haven't already noticed, whether it's on the right or left, mine in the end are always on the left. And I'm pretty sure back in my day, like that was a rule. It's never really been a rule, but I think my teachers, like when you're done, your variable's on the left. So it's okay if yours is not, but I flip mine around probably every time. That's just habit that's drilled in my brain. We good? Questions? All right, flip it over. Oh, yuck, right? Again, I'm not even gonna ask you which ones you want to skip on the back because it's probably all of them. 9 looks bad, is probably really not all that bad, right? Can we easily get rid of the fraction? Yes, okay. So let's multiply both sides by 2. And when you do that, do I distribute the 2 amongst the numerator on the left? No, the whole purpose of doing this is to cancel that 2 out, right? So this gives me 10x plus 17 minus x minus 9 equals, then I'm going to draw my little arrows and get 6x plus 2. Everybody good? All right, then you go ahead and finish this one up, and let's see what we get. Oh, what did I do? Did I do something wrong? Well, tell me where you were confused, though.
No, it's because you said don't distribute.
Oh, I'm sorry. Don't distribute the 2 in the numerator on the left, because that's what I said. Yeah, that's what I meant. Thank you. We do distribute it on the right. I have no idea what actually came out of my mouth, but that's what I meant. Ugh. And if your process is a little bit different than mine, is that okay as long as we get the right answer and we weren't making up math? Absolutely. All right, so if you have any questions about, if you're not finished, you can finish and then look at mine. And then we'll stop here for today. Okay, number 10, here we go. Do we want to start by distributing? No, would you rather start by getting rid of the fraction? At least one of them, right? We can't start by working on the inside stuff, but we can on the outside stuff. So what do we think we want to multiply both sides by? 8, very good. So we'll multiply both sides by 8. When we do that, these cancel out. We get 9 times 4 minus 1/2 a equals, then 8 times 3 is 24 times 1/4 a plus 5/2. Now, my next move was going to be to go ahead and distribute on both sides and deal with the fractions. Somebody paused me in second period and said, but first, couldn't we do what? Divide by 3, right? We can, those numbers out front, we can reduce those a little bit, which will make my fractions easier. So, which is fine. And either way, we'll get the same answer. But yes, if I multiply both sides by 1/3, sometimes we see those things and sometimes we don't. But if we do see them or take a second to look for them, our numbers get smaller and then things aren't as scary. So what is 9 times 1/3? 3. So I have a 3 out here times 4 plus 1. Oh, not plus. My goodness. 4 minus 1/2 a equals, and 24 times 1/3? 8 times 1/4 A. Notice how none of that is affecting what's inside my parentheses. That's another really common mistake people make, is making stuff up there. Now I can distribute. 3 times 4 is 12. Minus 3 times 1/2 is what? Don't overthink it. 3 over 2. 3 over 2, A. Equals, all right, 8 times 1/4. Shh. 8 times 1/4 is 8 over 4. What's 8 over 4? 2. 2A plus, and 8 times 5/2. You could cross cancel, but 8 times 5 is 40. 40 over 2 is 20. Now, what could we do next? Can we get rid of the fraction? By multiplying by what? 2. And I say again, every single term. I now have 4 terms, so I have to do 2 times this one, 2 times that one, and it's probably not a bad idea to actually write it out like that so that you don't forget one, because that's where the mistakes come in. So now we have 24 minus, well, those 2's cancel out, that's why I did it. 3A equals 4A plus 40. So I could move either A. I'm pretty sure I was trained to always move my letters to the left, but I would move the 3A so I could keep things positive. But you could do whatever makes the most sense to you. So I would get 24 equals 7A plus 20. 40? Oh my God. Jeez Louise. 40, not 20. I probably shouldn't have kept going. So then 7A, what's the difference? When I subtract, it's going to be negative. What's the difference between 40 and 24? 16. So I end up with A equals negative 16 over 7, which doesn't reduce. And Cassandra, ask me again about fractions. Do we want to leave it like that, or do we want to put a decimal?
I think we definitely.
We could do the decimal, right? What is the decimal? Do you know? Yes. See, just leave it and you're done. That's kind of why I like fractions better. All right. Those kind of numbers prove my point, right? We're done. We don't have to think about it any further. All right. Y'all good now? All right. We got 5 minutes left, but that's